Good morning friends. In the previous lecture we were solving the sums related to the distance formula, and in today's lecture friends we are going to continue with the next topic, that is the area of triangle. Now friends, as we all know that we have some 3 or 4 types of triangles that is available to us. Let us write down that. The triangles that we know are, the first one, that is a scalene triangle. Then the second one is an isosceles triangle. Then the third one is an equilateral triangle. And the fourth one is a right angle triangle. Right, these are the 4 main basic types of triangles that we know, that is scalene triangle, isosceles triangle, equilateral triangle or right angle triangle. Now in previous classes, that means in previous years, we also studied about a formula to find out the area of a triangle, that is the most basic one, area of a triangle, that is basically you can find it like half into base into height. Right, this formula was used to find out the area of a right angle triangle. This can also be used to find out the area of an isosceles triangle. This can also be used to find out the area of an scalene triangle. Also we know directly that area of an equilateral triangle, that is given by root 3 by 4 into side square. Right, as equilateral triangle has all the 3 sides equal or same, this can be written as root 3 by 4 side square. So that is the area of an equilateral triangle. And in standard 9 we studied about the Heron's formula. The Heron's formula was used to find out the area of a triangle, that is area of a triangle that is given by square root of s into s minus a into s minus b into s minus c, where s is equals to a plus b plus c by 2, which is known as, this s is known as the semi-perimeter of the triangle. A, B and C are the sides or the length of the sides of a triangle. So these were the 3 formulas that we have studied in our previous years or previous classes. But in this topic, in this chapter, we are going to discuss about such triangles where the length of the sides will not be given, but we will be given the coordinates of the vertices of the triangle. Right, so here if the coordinates of the vertices of the triangle are given, then the area of such triangle is given as follows. So if the coordinates of the vertices of the triangle friends means those points where any 2 sides of the triangles intersect each other. So if I draw any regular triangle here, then this A, B and C are known as the vertices of the triangle, and this vertices of the triangle will have some coordinates. So we shall assume that the coordinates of A are x1, y1, x2, y2 as B and x3, y3 for C. Friends, in the textbook if you clearly see there is some different method shown to find out the area of such triangle. But we are not going to follow that. We are going to use the simplest method as we only need the formula. We don't need the derivation, right? So here let the coordinates of the vertices of triangle ABC be A x1 y1, B x2 y2 and C x3 y3, right? Let the coordinates of the vertices of triangle ABC be x1 y1, B x2 y2 and C x3 y3. Then the area of such a triangle is given by A equals to half mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, right? Friends, this is the formula that you need to remember, that is somewhat different from the formula that is given in the textbook. This modulus, friends, it is not given in the textbook, but you need to remember it like this, that is half into modulus x1 into y2 minus y3. See, you need to follow the sequence x1, y2, y3, that is 1, 2, 3, then 2, 3, 1 and then 3, 1, 2. So you are going to follow the sequence here, that is 1, 2, 3, 2, 3, 1 and 3, 1, 2. First of all, see, all the x coordinates will be outside the brackets and only the y coordinates will be inside the brackets, that is 1 by 2 modulus. Modulus, friends, that simply means here, this modulus simply means negative will become positive and positive is already positive, because as the area cannot be negative, can you find out a negative area? Right? As area cannot be negative, modulus is applied, right? Modulus is applied. So modulus, friends, simply are two vertical lines in which some number, some variable is written. So if I say that modulus of minus 2, the answer will be plus 2. If I write modulus of 2, then also it will be 2, right? That means this modulus has a property of making the negative number positive. The negative number positive. Is it clear? So that we are going to use the modulus because area cannot be negative. So again I am repeating, area equals to half modulus x1 into y2 minus y3. So if we are taking the x1 or x coordinate of the first vertex, then we are going to take the y coordinates of the remaining two vertices. So x1 into y2 minus y3 plus x2 into y3 minus y1. Again, if I take x2 of the second vertex, then the y coordinates of the remaining two vertices as a difference, and x3 into y1 minus y2. So that gives me the area of the triangle so formed by the given vertices A, x1 y1, B, x2 y2 and C, x3 y3. So you need to remember this formula which will be used in this topic only. Is it clear? One more property related to this area of triangle is also there, that we will look in the further examples as we solve. Okay, so please mention this down, and then we are going to solve some examples related to the area of triangle. Okay. I am having a question here. The first one regarding the area of triangle. Find the area of a triangle whose vertices are 1 minus 1, minus 4, 6 and minus 3, minus 5. So this is the question given. Find the area of triangle whose vertices are given to us, right? So let us see how this can be solved. See friends, this is the easiest topic of this chapter, so don't complicate it here. Let the given vertices be A 1 minus 1 equals to x1 y1, then B minus 4 6 is equals to x2 y2, and C minus 3 minus 5 is equals to x3 y3. So we got all these three coordinates, x1 y1, x2 y2 and x3 y3. Therefore area of triangle ABC is equals to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula, and as we say that simply putting down the values of x1, y1, x2, y2 and x3, y3 in this formula, we get the result like that is equals to half modulus 1 into 6 minus minus 5 plus x2, that is minus 4 into y3 minus 5 minus minus 1 plus x3, that is minus 3 into y1, that is minus 1 minus 6, right? See friends, we have put the value as it is because here y3 is minus 5, so we have put it as minus 5, but this minus is different from minus 5 because this is already present in the formula. Here also y1 is minus 1, so we will put y1 as it is. Now we will solve this, the signs, right? That is equals to 1 by 2 modulus 1 into 6 plus 5, because minus minus is plus, here plus minus is minus, so that is minus 4 into minus 5 plus 1, and here again plus minus minus 3 into minus 1 minus 6 as it is. Is this thing clear or not friends? Right? So we have simply solved all of these signs here, that is plus minus minus plus and everything. Now we shall simply add them, that is 1 by 2 modulus 6 plus 5 is 11 11 into 1 is also 11 minus, sorry, let me first of all write down minus 4 into minus 5 plus 1, that is also minus 4. Okay, that is minus 3, and minus 1 minus 6 is minus 7. Is it clear? So that is equals to 1 upon 2 modulus 11 minus minus plus 4 into 4 is 16. Again minus minus is plus, 7 into 3 is 21. Okay. So 16 plus 21, that is 37. 37 plus 11 is 48. So that is equals to 1 by 2 modulus of 48. As you can see that 48 is already positive. So there is no need to make the modulus, that means no need to take the negative positive, right? That is equals to 1 by 2 into 48, which will be cancelled as 24. Therefore, area of triangle ABC so formed is equals to 24 square units, right? Is 24 square units. So that is the answer of this question, right? So that is how you use the formula of area of triangle with given three vertices, this 1 minus 1 minus 4 6 and minus 3 minus 5, as x1 y1 x2 y2 and x3 y3. Is this thing clear, friends? So that is how you use the formula. Let us solve some more examples so that we come to know exactly how is it possible. The second example I am having is find the area of triangle. Find the area of triangle formed by the points A 5,2, B 4,7 and C 7, minus 4. Right? So we need to find out the area of the triangle that is formed by these points. Let us see how. Here, let A 5,2 equals to x1 y1, comma B 4,7 equals to x2 y2 and C 7, minus 4 is equals to x3 y3. So these are the 3 points that we have taken as x1 y1, x2 y2 and x3 y3. Therefore, area of triangle ABC, that is given by the formula half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula, friends. Now using this formula and putting the values that we have here as x1 y1, x2 y2 and x3 y3, what do we get is half modulus 5 into y2, that is 7 minus 4 plus x2, that is 4 into y3 minus 4 minus 2 plus x3, that is 7 into y1, 2 minus 7. Okay. So that is how we put the values here. 1 by 2 modulus 5 into 7 minus 4 plus 4 into minus 4 minus 2 plus 7 into 2 minus 7. Let us solve this again. So that will be equals to 1 by 2 modulus 5 into 7 plus 4 plus 4 into minus 4 minus 2, that is minus 6, plus 7 into 2 minus 7, that is minus 5. Is this thing clear? So that is the values that we can put here as and solve it. So 7 plus 4, okay, let me write down 1 by 2 modulus. 7 plus 4 is 11. 11 into 5, that is 55. Plus, will it be plus? No, it will be minus, because plus into minus is minus. 6 into 4, that is 24. Again, plus into minus is minus, and that is 35. Right? What is 55 minus 24? That is 31. Right? 31 minus 35, that is minus 4. So that is equals to 1 by 2 modulus of minus 4. Now you can see here, friends, that here in this case we have modulus of minus 4. So as I said that what is the property of modulus? Modulus makes the negative number positive. So here we will write this as 1 by 2 into 4, because that negative number will be changed to positive and the modulus will now be removed. So that is 1 by 2 into 4, which gives me 2, and hence therefore area of triangle ABC is equals to 2 square units. Okay, that is equals to 2 square units, because that 1 by 2 and 4 can be cancelled with 2. So that is the answer, that area of this triangle so formed will be 2 square units. Is it clear? Okay, so now I am going to erase this. Going to solve the third one here. That find the area of triangle formed by the points P minus 1.5 comma 3, this is 1.5, friends, Q 6 comma minus 2, and R minus 3 comma 4. Right? So these are the 3 points given to us: P minus 1.5 comma 3, Q 6 comma minus 2, and R minus 3 comma 4. So let us solve this. Here let P minus 1.5 comma 3 is equals to x1 y1, Q 6 comma minus 2 is equals to x2 y2, and R minus 3 comma 4 is equals to x3 y3. So we have taken these 3 points as x1 y1, x2 y2, and x3 y3. See friends, make a habit that whenever these type of 3 coordinates are given, you will take the coordinates in order only, right? That means the first point will be x1 y1, the second point will be x2 y2, and the third point will be x3 y3. So it will be easier for you to tally the answer. Therefore, area of triangle PQR, that is equals to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Therefore, we get the values here, that is half modulus x1, that is minus 1.5 into y2 minus 2 minus 4 plus x2, that is 6 into y3 4 minus 3 plus x3, that is minus 3 into y1 3 minus 2. So that is the formula and that is the values that we have put here. Okay, let us solve this. That is equals to 1 upon 2 modulus minus 1.5 into minus 6 plus 6 into 1 here plus minus 3 into 3 plus 2. Okay, so that is what we have solved the signs here. Now let us multiply everything. That is 1 by 2 modulus minus 1.5 into minus 6. First of all, minus will become plus, so you can simply remove this minus and minus. 1.5 into 6, that is 9. Here 6 into 1 is 6, and here 3 plus 2 is 5, and minus 3, that is minus 15. So as you can see friends, that if I add these all numbers, what is 9 plus 6? 15, and 15 minus 15 is 0. So you can say that half into modulus 0. 0 is nothing, neither negative nor positive. So it will be a neutral number, hence it is 0. So what if, therefore, area of triangle PQR is equals to 0 square units. So what does this mean? That if the area of any triangle is 0 square units, then what does it conclude or what does it mean? How can you get a 0 area? Suppose that if I am having a triangle, here with 0 area, if the area is 0 actually, will this vertices form a triangle? No, right? Because if I say that I am having a land of 0 square acres or 0 square kilometers, is it possible? No, as we say that distance is never 0. We cannot measure the distance in 0 or in negative. In the same way, we cannot measure the area such that it has 0 square units, and simply this means that if the area of any triangle is 0, then the vertices of the triangle given are collinear. This is important. See friends, this is coming back again, collinear. We have seen these terms collinear in the distance formula also, right? And this is again coming here, that if the area of any triangle, this is triangle, is 0, then the vertices of the triangle given are collinear. Collinear, that means all the vertices will lie on the same line. So this triangle will now not be a triangle. In fact, these vertices will be collinear. So if this is B, this will be, and this is C, right? So that actually forms a triangle, but this triangle is having the area as 0 square units. Is this thing clear? So from this I would like to conclude one point, that I am writing it here. conclusion from this illustration number 3 or the question number 3, that if the area of any triangle is 0, then the given points are collinear. Right? That if the area of the given triangle or if the area of any triangle is 0, then you will be given some points to find out the area of the triangle. Right? That points given to you will be collinear. So, if the area of any triangle is 0, then the given points are collinear. And second, if 3 points are collinear, then the area formed by those 3 points is 0. The points are vice versa. That if the area of any triangle is 0, then the given 3 points, let me write down one more thing here, that the given 3 points, because whenever you have a triangle, at that time you will be given 3 points, right? That means if the area of the triangle is 0, then the given 3 points are collinear. As I said again, that the first point reveals a situation like we are having a triangle with B and C as this side, but the area is 0, so the point that must be here will now be exactly in between B and C, right? It should be like this, so as to form a triangle, right? It should be like this, so as to form a triangle, but the area is 0. So if the area is 0, then this point here will now be on this line, and hence you can say that A, B and C are collinear as B dash A dash C. They will be collinear. And if these 3 points are collinear, that means if these 3 points are collinear, then we can also say that the area formed by these 3 points, the area so formed by these 3 points is 0, because these 3 points given to you does not form any figure, 3-dimensional figure, or let us say 2-dimensional figure. They simply forms a straight line. Hence you cannot get the area of a straight line. Is this thing clear, friends? So that is how these points are being concluded. Okay. So I think you must note this down, these 2 points, so that it will be helpful for us to solve some of the examples here. Okay, note it down, then we solve the example. Okay. Now, the fourth one, find the value, find the value of K if the points A 2 comma 3, B 4 comma K, and C 6 comma minus 3 are collinear. See, as we seen the previous points, the very next example is that find the value of K if these 3 points given to us are collinear. So here given that A 2 comma 3 is equals to x1 y1, B 4 comma K is equals to x2 y2, and C 6 comma minus 3 is equals to x3 y3, right? And also given that A, B and C are collinear. So area of triangle ABC is equals to 0 square units, right? We know that the points A, B and C are collinear points, and as these three are collinear points, what did I say? That the area of that triangle so formed will be 0 square units, right? That was the second point here. Yes or no? Okay, therefore putting down the formula, half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. So this 1 by 2 will go over there and it will become 0. Therefore modulus, putting down the values, x1 that is 2 into y2, what is y2? K minus 3 plus x2 that is 4 into y3 minus 3 plus x3 that is 6 into y1, what is y1? 3 minus k is equal to 0. Yes or no? So we just put down the values here that we got from these 3 points, or that was given with these 3 points. Therefore modulus 2 into k minus that will become plus 3 plus 4 into minus 6 plus 6 into 3 minus k is equal to 0. Okay, so that is how we get after simplifying these values. Therefore modulus 2 into k plus 3, this 2 will be multiplied with k and with 3 both, so 2 into k is 2k plus 2 into 3 is 6 plus minus 4 into 6 24, here that will be 6 into 3 18 plus minus 6 into k is 6k is equal to 0. Okay, therefore modulus 2k minus 6k that is minus 4k, 6 plus 18 that is plus 24, minus 24 is already given equals to 0. So we can directly cancel out plus 24 and minus 24. Therefore modulus of minus 4k is equal to 0, and hence 4k is equals to 0. This implies k is also equal to 0. So friends, we got the value of k here, that is k equals to 0. You can also verify by putting it 0 in place of 4 comma k, that is 4 comma 0. you will get the point as 4 comma 0, and whether you are getting the area equals to 0 or not, that you will be verifying by yourself. Okay, so that is how you can find out the value of k, that is the value of unknown coordinate that is given to us. Okay, is this thing clear, friends? Now I shall give you some questions that you will do it by yourself. The homework: find the area of the triangle formed by the given 3 vertices. The first one, that is 2 comma 3 minus 1 comma 0 and 2 comma minus 4. The second one, minus 5 comma minus 1, 3 comma minus 5 and 5 comma 2, right? So these are the two examples that you will do in homework. Okay, so in the next lecture, friends, we shall solve some more examples related to the area of triangle. Is this thing clear?